Hi again. The following question involves graphing a cubic polynomial and then using the graph to solve an inequality. Let's solve part 1 of the problem, where we're asked to sketch the graph of the cubic function and state the intercepts of the graph with the x and y axes. We'll do this by analysing the function step by step. The first thing to consider is the end behaviour of this graph. We see that if we were to expand the cubic function fully, the leading term is -2/5 x cubed. We can say that this function belongs to the negative x cubed family of graphs. That is, the exponent is 3 and the coefficient is negative. What this means is that our graph starts in the top left quadrant here and ends in the lower right quadrant. In fact, any cubic function with a negative leading term will exhibit this end behaviour. Next, we'll find the x-intercepts. To do that, we'll let y equal 0 in our original function. We can see that our function is already factorised, so that simplifies our problem. We can say that if x plus 2 equals 0, then x would be -2 from this first factor. If 2x minus 1 equals 0, x will be equal to a half. And if x plus 5 equals 0, x will be -5. That's what we call the null factor law. And this is one way that we can use to find the x-intercepts. So our x-intercepts are -2, a half, and -5. The next thing to do is find the y-intercept. And to do that, we'll let x equal 0 and substitute 0 into our function. And by calculation, we'll find that y equals 2. So 2 will be our y-intercept. The next step is to draw the graph. So mark down your x-intercepts, which are a half, -2 and -5, and the y-intercept is 2. And we know that by our end behaviour that the graph starts in the top left quadrant and ends up down in the bottom right quadrant. So we pass down through the first x-intercept, we turn through -2, up, turn through the y-intercept, and then continue down. In part B, we want to solve the inequality -1/5 x plus 2 times 2x minus 1 times x plus 5, where the function is greater than or equal to 0. What we need to do is look for the values of x where the graph equals 0 or takes a positive value. So this is our graph from the last part, and we can see that our function would take positive values here above the x-axis. The function equals 0 on the x-axis, and the function is less than 0 below the x-axis. And we're interested in where our function is positive or equal to 0. Our final solution set then is all x values between a half and -2 inclusive, and also x less than or equal to -5.